Sometimes a function is defined using different equations on different parts of its domain. When we have a function like this, we call it a piecewise defined function. So we are going to evaluate each piecewise function for the given value. So we have the piecewise function f of x equals x plus 3 if x is less than -2, and negative 2x minus 3 if x is greater than or equal to -2. So we're going to evaluate f of -5. And the first thing you should do is look for what's inside the parentheses, in this case, -5. And we're going to take this and see which one does it fit into on these restrictions here, either the top one or the bottom one. And it's only going to work in one of them. So, is -5 less than or equal to -2? And the answer is yes, it is. So that means we're only going to be using this function here, x plus 3. So we're going to have -5 plus 3, which is going to give us -2. And that is the answer for the first one. Next, we have f of -2, and again, we're going to plug it in. So if we plug into the first one, is -2 less than -2? The answer is no. So it can't be the first one. And is it the second one? Is -2 greater than or equal to -2? And it is equal to. So we're going to be using the bottom equation, which means we're going to have -2 times -2 minus 3, which is going to give us 4 minus 3, which will be positive 1. And we're going to do the same thing for f of 0. Is 0 less than -2? The answer is no. Is 0 greater than or equal to -2? And the answer is yes. So it's going to be the bottom equation again. So -2 times 0 minus 3 is going to be 0 minus 3, which is going to be -3. So our answer for the second one is -3. Now what if we got 3? We do the exact same thing again. So what we're going to do is we're going to start off with g of 0, and our x value is 0, and we have the choice of either 2x plus 1 if x is less than 0, 7 if x is 0 less than or equal to x less than 4, or 5x squared if x is greater than or equal to 4. It's going to be one of these three. So taking 0, we plug it into the first one, 0 less than 0, which is obviously not true. So it can't be the first, so we'll try the second one. 0 less than or equal to 0, which is true, and it's less than 4, which is obviously true. So that means we're going to use the middle one. Now, there's no x value to plug in 0, so all we have is 7. So 7 is our answer. Next, we're going to do g of 3. Again, we do the first one. Is 3 less than 0? It is not. Next one, is 3 between 0 and 4, inclusive for 0? And the answer is yes, it is. So again, we use 7. And there is no x value to plug in 3, so 7 again is our answer. Now we have 4, g of 4. It's not going to be the first one. 4 is not less than 0. It's not going to be the second one because 4 is not less than 4. It's going to be the third one. 4 is greater than or equal to 4. So we're going to use 5x squared. And so we're going to get 5 times 4 squared. And you evaluate that, you're going to get 80. And there's your answer. And last, we have g of 5. Obviously, it's not going to be the first one because it's not less than 0. It's not going to be the second one because it's not between 0 and 4. It's going to have to be the third one because 5 is greater than or equal to 4. So we're going to use 5x squared again. So 5 times 5 squared. And when we evaluate that, we're going to get 125 as our answer. Now you can see from here, didn't use the first one, and that's okay. You don't have to use all of them. You just use what's given to you. If that means one equation is not used, then you just skip it.